Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 19 of our 30 LeetCode challenge, and the problem which has been given to us today is search in rotated sorted array. We've solved a similar problem like this before in our previous videos, so if you want a detailed explanation of a simpler approach, you can find it in the description below. And if you want to try solving this problem on your own, you can find the LeetCode link also in the description. So let's just dive right in. So the problem description is: suppose an array sorted in an ascending order is rotated at some pivot unknown to you beforehand. So you have this array and it's been rotated, and it's still sorted if you sort of assume that this is your starting point, and you can see 0, 1, 2, and then you have 4, 5, 6, 7. So you're given a target value to search, and if found in the array, return its index, otherwise you return -1. Pretty simplistic. And the key part about this particular video that we're going to talk about is this assumption right over here. So the assumption is that there are no duplicates existing in the array, and that sort of converts your algorithm a little bit. If you look at my previous video, what you will find is that we're using a modified binary search way in which we are using the recursive calls just to identify, hey, do I go on my left side or do I go on my right side? And that is fair, but the only thing that it doesn't work on is if there are duplicates inside your array, and that just sort of breaks everything. So to handle those duplicates, what you would want to do is you would want to use a pivot, sort of try to understand where the pivot really lies, and then sort of move forward or do your binary search from there. So since we've already gone through the previous approach where we assume that there are no duplicates existing in the array, what we're going to try to do today is that we're going to assume that there are duplicates inside the array and code out the other solution. And obviously you have this constraint that should be a log of n. And you've been given a few examples over here. You can pause the video and check them out. So let's just dive right in. What I'm going to do today is that my approach might not be log of n for certain conditions, but for certain conditions it will be log of n. And the reason why I'm doing that is just because you have a better foundation of understanding how I would use the pivot to identify where the pivot really lies, and then sort of move forward from there. That's the only reason why I'm sort of doing it in this fashion, and you'll see what I'm talking about in some time. So let's start with the base condition, which is just going to be, hey, if there are no numbers which have been given to us, then you return -1. And now what we want to do is we'll take a step back. We'll try to understand how can we use the pivot element logic to sort of move forward. So let's make this a little interesting. We'll use recursion as well as not use recursion. So what I mean by that is that to find the pivot element, we'll use the recursive binary search, and for like after we use the pivot, we use an iterative sort of a binary search way. So a simple way to find the pivot is just by defining a function, which you all know, and you have a low and a high. It's pretty straightforward. And a break condition is just going to be like if low is greater than high, then that would mean that you've not found your pivot. In that case, you return -1. Or actually, we can just return none over here because we can handle that a lot more easily. So what we want to do over here is that we want to first identify what's going to be the mid. So mid is pretty straightforward. That's just like a mathematical formula, which is just going to be low and high, and you just divide that by 2. Before we sort of go into the nitty-gritty details of what's going to happen in the pivot, let's just sort of define what the pivot would sort of look like. So the pivot is going to take in 0 as its starting point, and the length of nums -1 as the highest point. So basically looking at what's the lowest point, what's the highest point, and then you got to sort of move forward from there. So now what we're going to try to do is we're going to try to identify whether there is a mid somewhere using the mid value itself. So what we can do is we can say, hey, if now num's mid, and do note over here, this is where things will start to get a little tricky. So when you have nums mid and it's greater than nums mid +1, that would ideally mean that there's a swap happening. The only condition where this would happen is like, let me just copy this guy really quick. So, so the only place where this would happen is if you have nums mid like this, and your 0 is the next element over here. So when that happens, you would want to return the pivot index. So the pivot index is this guy. So we just do return mid plus 1. Similarly, if we have mid over here, then we sort of check the previous value to that and see whether it's less than that. So pretty straightforward, just do mid minus 1 is greater than nums mid. If that is the case, then you return a mid. Pretty okay, not that complicated. Now we just use the logic of understanding where do we go if we don't really find anything. So we check, hey, if nums low is going to be greater than nums mid. Now you can sort of look at this thing. That's why I sort of pasted this example in. So let's say that the mid is this guy, this is 7, and 4 is the, or actually, let's just say for now, for instance, just like 1 is the mid, even though it's not. Let's just assume that it is, and 4 is the lowest value, or 4 sort of resides in the lowest index. So in that case, what you would want to do is, for a fact that it's the pivot is somewhere over here. So all you do is you would sort of change the highest index and just change that to mid minus 1. So basically do a return, and in a recursive fashion, all we do is we just say pivot low and mid minus 1. So that sort of gets replaced with the high, and then you sort of move forward with that. Similarly, um, if you have nums mid, which is greater than nums high, then I mean, you can sort of jot this out already, but we just change the low value to mid plus 1, and the high sort of remains the same. So if you sort of select this guy over here, and let's say that this is the mid, or sort of, okay, let's look at this thing because this is the mid. So 7 is the mid over here, and let's say that there is 8 over here as well, something like that. And when that would happen, then you know that your pivot is somewhere over here. So you just have to like take a lot of examples in this problem to identify how you would move forward with this. But do note that this works for um, this properly works for duplicates as well, with a few adjustments though. Now there are a few problems here. Now the problem is that you're doing mid plus 1 and you're doing mid minus 1, and that sort of dictates an assumption that the length of the array is always going to be greater than 2. Um, just I mean, you can sort of modify this and you can make this a lot more better, but just so that we do this a little more quickly, I'm just going to say if length of nums is less than 3, then finding something is just going to be like a little quicker. So I'm just going to say return the nums of index of target if target is in nums, otherwise you return minus 1. And this is not a login solution, but you just have two indexes, so it really doesn't matter, to be honest with you. Speed wise, it's the same thing almost. Um, and you can modify this pivot to like sort of handle or try catch those elements, but I don't want to do that. That just makes it a lot more messy. So now what we've done is we found the pivot, and there would be a case where pivot would be none. So we just checked, hey, if p is none, sorry, if p is none, then you make p equal to 0. Because do note that there might be a case where they have not rotated the array and it's in the same sorted array. So if you have stuff like 1, 2, 3, and they've not rotated it, the pivot would be 0. So it would still be 1, 2, 3. I hope that sort of makes sense. Now what we're going to do is we did a binary search in a recursive way. Now let's do it in an iterative way as well, just to make this problem a little bit more interesting and harder. So let's just say that the low is just going to be the same thing as we did before. Low is going to be 0 at the starting point at least, and high is going to be length of nums minus 1. Obviously, when you do it iteratively, the break condition would just be when low is greater than high, similar to this guy over here, and you sort of just iterate forward as you sort of move through the solution. Eventually, if you don't find anything, you're going to do return minus 1. So that's pretty straightforward. And if you find something inside this loop, you return it at that particular moment of time itself. Now what you want to do is you just want to calculate mid, that like we did before. So you do low plus high divided by 2. And this is where the pivot is actually going to help us out a lot. So let's just make a quick variable called it as val. Doesn't really matter. And what I'm going to do is inside nums, instead of just doing mid, what I'm going to do is I'm going to add the pivot element as well. And since it might go out of bounds and I want it to remain inside the bounds of the condition, so I'm just going to do length of nums. So if you have a pivot of 4 and your mid is somewhere inside um, is greater than 4 or something like that, then I don't want it to go out of the array. So this is just to control the bounds, and eventually it sort of goes back as well. So what you essentially have is that you have the mid when considering the pivot as well, and then sort of you can move forward with the solution. So essentially what you've done is you've broken this problem down into a normal binary search. And all the var is doing is just using the pivot to identify like what exactly is the true mid. So if you look at this example, I would say that the true mid would probably be 4, I would assume. So if you start at the mid, you look at the mid as over here, you add, and this index is also 4, I believe. So you do 3 plus 4, which is 7, and 7 is the length of the array, so it becomes the true mid becomes this guy over here. And then you can use that to identify whether you go left or whether you go right. So pretty straightforward. So you just first check by saying that, hey, where the target is actually equal to the value that we've got so far, and then in that case you just return this guy. Otherwise it's pretty straightforward. If the value is less than target, then it's the same thing like you use for binary search. You just update the low value to take in the mid, otherwise you update high to take in mid minus 1. Yeah, so if you don't know what's happening over here, a quick explanation. Value is the true midpoint. So if the true midpoint is less than the target which has been given to us, well, let's just jot this down. Let's say that we have the sequence. So the mid would be this guy too, and you have 4 over here, and you want to find 4. So if you know that the true mid value is 2 and the target that you want is 4, then you update the low. So you change this low to come over here, rather, and otherwise the same thing. So it's exactly like binary search. You've ideally just broken down this problem into just finding the pivot and then using a simple binary search. So let's just go ahead and run this code. Hopefully this should run fine. I'm assuming that there are no faults. Okay, cool. So it is running, and let's just go ahead and submit this. Whoops, it's not running. So let's just see what's going on. So num is not defined. Oh, I know what's happening. Yeah, that should do it. It's weird that this condition didn't get caught before. Anyways, so the submission has been accepted, and awesome. So that's basically it for today's video. So just we'll do a quick recap and then we'll switch off this video. So what we've done is we know that we need to find a pivot. So we've sort of made a function to calculate the pivot. The only assumption for the pivot is that the length of the numbers is greater than 2. It's just because of this mid plus 1, and you can put in extra conditions just to check whether mid plus 1 is actually existing inside nums or not. But if you're doing that, then the array is actually pretty small, so you can just do a quick thing. Nums index actually returns the index of any target value, at least the first index. And the same thing over here for your normal thing. As you sort of get the pivot, you check whether it is none. It will only be none if low is greater than high. If that's the case, then that means that the rotated sorted array is the same thing as a sorted array, so that means there are no rotations, which means that the pivot is actually equal to 0. And then all we're doing is we're just doing these computations where we just check whether we just do a simple iterative binary search. The value is pretty straightforward. The only catch over here is that you add the mid that you've sort of calculated and you try to find the true mid. And once you have the true mid, you can sort of use the simple binary search approach to just identify where the target would be, and that would sort of run in log of n as well. So awesome. Again, if you did not understand something or if you have any suggestions, do leave it in the comment section below. I love to hear from you guys, and I'll always try to respond as quickly as I can to the comments. And if you did like this video, do give a like and do subscribe to our channel. We are a discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it. And have an awesome day. Thank you.